Let us see some problems of the mole concept. So I have collected some of the problems, so we'll see one by one problems in different mode. So let us see this problem. What is the number of neutron in 5 gram of D2O? So number of neutron means D2O contains how many neutrons. So we know D2O is called as heavy water. So D2 is called as heavy water. So heavy water means this D contains 1D contains 1 proton plus 1 neutron. Okay, and oxygen contains 8 protons plus 8 neutrons. So what is number of neutrons? 5 gram water. So first we have to convert this 5 gram into mole. So because they are asking mole, so mole means we have to use this formula. Number of mole is equal to weight of substance by molar mass of water. Water means here heavy water. So first we need to convert how many neutrons are present in them. So 5 gram means how many moles is there. So 5 gram means number of moles will be 5 gram divided by, and D is, we know that D is how much, it is 2 gram. So there is 2D into 2 plus 1 oxygen. This 1 oxygen is 16. So this becomes 5 plus 4 plus 16. This becomes 1 by 4. 5 upon 20. So this is nothing but by 1 by 4 mole. Now let's take if you take 1 mole of D2O, if 1 mole of D2O, so in 1 mole of D2O here, not 1 mole, 1 molecule of D2O. So 1 molecule of D2O contains 1D contains 1 neutron, so 2D contains, so 2D will be your 2 neutrons, and there is one oxygen. So 1 oxygen contains how many? 8 neutrons. So there will be total neutrons. So if you take 1 mole, D2O, so this will contain how many? 10 moles. But we have how many moles? We have only 1 by 4 moles. So 1 by 4 moles contains how much? So 1 by 4 moles D2O contains how much? 10 into 1 by 4, that is 2.5 mole. So this is the answer. This much neutron is present in D2O. So now we will see second problem. So second problem is we can see here cisplatin is a compound. So it is an anti-cancer drug. And whose molecular formula is platinum NH3 whole twice Cl2. This is the formula. What is the mass in gram of one molecule? So they are asking one molecule, what is the mass of one molecule? So for molecule, again this is question belong to number of particles. So again we can use same formula. So number of mole is equal to same weight by molar mass. Weight by molar mass of the substance. Weight of one molecule they are asking. First if we find the number of moles, then we can use this formula. So let us find first molecular mass of the substance. So molecular mass of platinum is how much? Platinum NH3 whole Cl2. So this is nothing but it will come around. So platinum is 195. So 195 plus this ammonia. So ammonia will be 2 into nitrogen is 14 plus 3. So this comes 17. So 2 into 35.5. So it will come around 195 plus this is your nothing but your 34, and this will come your 71. So total will be 300. So this is the 300 is the total value. So for one molecule they are asking, so number of moles will be if you take 300 gram. So 300 means 1 mole contain 1 mole of cisplatin contains how much? 300 gram. Okay, so if you take one molecule, so it will be how much? 300 divided by 1 mole. So 1 mole we know very well. So 1 mole is nothing, 6 into 10 power 23. So we will divide here 6 into 10 power 23. Okay, so this will be your answer. So answer will be your how much? If you divide it, something is coming 5 0.65, so it will be 50 into 10 power 23. So roughly it is coming 5 into 10 power, it is minus 23, so it will become 5 into minus 22 molecules, 5 into 20 gram. So this is the weight of one molecule of gram. This is the answer. So it is very easy. If you remember this formula, so with the help of use formula we can calculate this value. Now we see third problem. So third problem is our we can see here aspirin. Aspirin has the formula C9H8O4. So this is the formula of aspirin, and how many atoms of oxygen are there in a tablet weighing 360 milligrams. So again it is the concept number of atoms. So again is the problem of number of atoms. So number of atoms, so it is the first, again same formula. So number of atoms means weight by molar mass. So again weight they have given, so number of mole is equal to weight upon molar mass. Again same equations, weight upon molar mass. So weight is how much, molar mass we have to see. Weight they have given 360 milligrams. So milligram we can convert into 360 into 10 power minus 3. Okay, and molar mass is how much? Molar mass is C9. So C9 will be how much? It will be your almost 12 into 9. 12 is the molar mass of carbon, 8 carbon molar mass of hydrogen 1 gram, and oxygen is 64 into 16, 64, 16. So this will come something around 108 plus 8 plus 64. So this will come around how much it is, 108 plus 8. So this will be your 672 plus this will come 180. You can calculate, this is 180 gram. So now we can use here. So number of mole, this is equal to number of mole. Number of mole is equal to 360 into 10 power minus 3, and again divide by 180 gram. Okay, so if you know number of moles we can calculate this one. So this will becomes how much? Divide by 2, so 2 into 10 to the power minus 3. So this is the number of moles. Okay, so now we require how many atoms of oxygen are there. So if you take 1 mole contains 4 moles of oxygen. 4 moles of oxygen. Okay, so then 2 into 10 power minus 3 mole contains how many? 1 mole of this one aspirin. 1 mole of aspirin contains 4 moles of oxygen. So if you take 2 into 10 power 3 moles, okay, then how many moles of oxygen? So 4 into 2 into 10 power minus 3 moles of oxygen. So this will become how much? If you take, if you multiply by Avogadro number, this is nothing, 8 into 10 power minus 3. But this is the moles of oxygen. So they are asking moles of atoms. So moles of atom is minus 3 into 6 into 10 power 23. So this will give you 48 into 10 power 23, or you can write 4.8 into 10 power 22 atoms of oxygen. Atoms of oxygen. So this is our answer. So in this way we can solve one by one problem. Let us see next problem. So next problem is question number 4. 20 gram of an ideal gas. 20 gram of an ideal gas contains only atoms of sulfur and oxygen, and occupies 5.6 liter at atmosphere 1 atmospheric pressure and 273 Kelvin. What is the molecular weight of gas? What is the molecular weight of gas? So again we see what is the meaning of ideal gas. Ideal gas means those gas which occupy at STP means 1 atmospheric pressure and 273 Kelvin. So they will occupy always 22.4 liter volume. So 1 mole of any gas, so they will occupy how much? 22.4 liter. So this we have to remember at STP. So again we have same formula. So they are asking what? Molecular weight. So first we will find moles. So number of moles for volume. If you take volume of gas, so we write here volume of gas divided by molar volume. divided by molar volume. So again we know how much volume is there, 5.6 liter divided by 22.4 liter. This is coming something about 1 by 4 mole. 1 by 4 mole. So what is the molecular weight of the oxygen? So we know the mole. We are knowing this mole. So this number of 4 mole is there, and weight is how much given? They have given 20 gram. So molecular weight will be, so again this is equal to weight by molar mass, because number of moles in terms of volume, this is in terms of mass, in terms of mass. So this will becomes how much? So weight is equal to 20 gram, weight is equal to 20 gram, and molar mass we don't know, but volume is how much? 1 by 4 mole. So molecular mass is equal to 20 into 4, that is 80 gram. So this is 80 gram is the molecular mass of the gas which contains sulfur and oxygen. So next we will see next problem. So next problem is a sample of ammonium phosphate contains 6 moles of hydrogen atoms. What is the number of moles of oxygen atoms in the sample? So this is the question comes. So again we can see here in NH4 whole 3 phosphate. So this contains how much hydrogen? If you take 1 mole, this is the 1 mole, actually it's 1 mole, nothing is 1 mole. So 1 mole contains how much? 12 moles. Okay, and oxygen contains how much? 4 moles. So hydrogen is 12 moles in 1 mole, and oxygen how much? 4 moles. So now they are asking if some moles is there, 6 moles of hydrogen, some moles is there, what is the number of moles of oxygen atoms in the sample? So in this, hydrogen contains how much? 6 moles. Okay, so how much oxygen will contain? So very simple. So if you take hydrogen 12 moles, then oxygen contains 4 moles. Now if hydrogen contains how much? 6 moles, then oxygen contains how much? So it is nothing, 4 divided by 12 into 6, so it will be your answer 2. So 2 is the actually answer. So 2 moles of oxygen atoms are present in the sample. So this is the next answer. Next is 6. So in this 6 we can see, so if a mole were to contain 1 into 10 to the power 24 particles, so what would be the mass of 1 mole of oxygen and a single molecule? So 1 mole of oxygen, so you can see here 1 mole of oxygen mass will be same, it will be same, means how much? 32 gram, because number of particles is 32 grams, only contains 24 particles. Okay, now what is the mass of a single oxygen molecules? So mass of single oxygen molecules will be, mass of single oxygen will be how much? So total weight is how much? 32. So 32 divided by total particle is 24. So answer will be 3.2 into 10 to the power minus 23 grams. So this is the actual answer. So now see next. So which of the following contains the largest mass of hydrogen atoms? So largest mass of hydrogen atoms means if the atoms contains more moles, more weight will be there. So we have, our main target is to which of the following options contains more moles of hydrogen. Which of the following contains more moles of hydrogen? So if you see here, A contains 5 moles of C2H2O4. So 5 moles means 1 mole is 2 mole. So 5 mole will be, so 5 mole will be 5 into 2 means 10 moles. Okay, come to B. So here 1 mole contains 8 mole. So 1 mole will be how much? 1.3 into 8. So this will be your 8.8 mole. Similarly, see 1 mole contains 8 mole. So 1.5 mole will contain 1.5 into 8. So this will be something 12 mole. Similarly, D 1 mole contains 4 mole. 1 mole contains 4 mole. So 4 mole contains 4 into 4, 16 mole. So now we can see more number of moles, more largest mass of hydrogen atom. So this is the more number. So answer will be your D. So this contains largest mass of hydrogen atoms. Now next. we'll see. So we'll see one by one good problems in mole concept. So here, so it is known that atoms contains proton, electron, neutrons. So if the mass of the neutron is assumed to half of the original value, so whereas that of proton is assumed to be twice of its original value, then the atomic mass of carbon C14 will be how much? So we have given option 14.28%, 14.28% more, or 28.56% less. So we see here, if the mass of the neutron is assumed to be half of the original value. So if the mass of the neutron, suppose you take carbon C14 6. So here neutron is how much? Neutron is 14 minus 6. So here we have neutrons 8, and how much is proton? Proton is how much? Proton will be your 6. So 6 protons and 8 neutrons. Now they are telling now new mass is, new neutron is how much? Mass of new neutron is n by 2, and new proton is how much? 2p. Okay, this is new proton. So total weight is number of weight will be how much? So n by 2p. So n by 2 will be how much? So yes, you multiply it, n by 2 into 8. So we are getting how much? 4n. And here you will get 2p. So 2p is 6. So 6 into 2, how much? 12. So we will get here 12. Okay, so here the total number of particle will be how much? 16. 12 plus 1. This is the empty mass. So here mass will be your how much? This is half. So it will be your 4n. This is your 12n. So total mass will be how much? For proton plus neutron, new proton, total mass. So it will be 4n plus 12n. This will be your 16n. So there will be total 16n. Okay. So the mass is, original mass is how much? If you say original, so original is, that is 14, and new is your 16. So new is 16, old is your 50. Say old is your 14. So what will happen? So there is an increase of how many mass? 2 mass. There is an increase of 2 mass. So increase in mass will be how much? 2 upon 14. So if you write in percentage, it becomes how much? 100. So it will be answer 1 upon 7 into 100. So this will comes 14.2% more. So this will be your answers. Now see next. Caffeine has a molecular weight of 194. So if it contains 28.9% by mass of nitrogen, number of atoms of nitrogen in one molecule of caffeine is. So a molecular mass they have here 194. It contains 28.9% by mass of nitrogen. Okay, so now if you take 100%, means if you take here 100%, so in 100%, 100 gram, 28.9 gram is nitrogen. So number of atoms of nitrogen in one molecule of caffeine only. So first we have to find in 94 how much nitrogen is there. If you take here 194 gram, so you will get 28.9 divided by 100 into 194. So we will get here 56 gram. So total gram of nitrogen 56, and we know that 14 gram contain 1 nitrogen. So for 56 gram it will be how many nitrogen? 4 nitrogen. So answer is 4 atoms of nitrogen in one molecule. One molecule, if you take AMU you are taking, this will be one molecule. Okay, if you are taking mole, this will be 4 moles of atom. So be careful writing. Okay, 4 mole is different and 4 atom is different. So 4 atom is 4 AMU. 4 atoms means 4 AMU, and 4 moles we know very well. Now see here next. So next problem is this one. So we see here, in 200 milligram of carbon dioxide, 10 per 21 molecules are removed. How many moles of CO2 are left? Okay, so again you can see here total weight they have given, and this much molecules are removed. How many moles of CO2 are left? So you first write the total weight of mass of moles of CO2. total moles of CO2. The total moles of CO2 will be weight by molar mass. So weight of CO2 is how much? 200 milligram means -3 weight of CO2, and molar mass is how much? 44. So this become moles of CO2. And removed is how much? 10 to the power 21 is the moles, and number of molecules is 6 into 10 power 23. So total moles of CO2 left. Okay, so this is the total number, and this is the total is removed, so this is left. So this will becomes how much? If you solve it, you will get it up to something 0045, and if you solve this one, you will get here 0.00167. So on getting, you will get answer 0.00283. So this much moles of carbon dioxide left.